In this video I talk you through how to combine uncertainties. So first we need a few symbols. The absolute uncertainty is what we tend to write after with a plus minus symbol with the same units as something. So for instance, a length is 30.0 plus or minus 0.1 centimeters. The absolute uncertainty, delta L, is 0.1 and the actual value is L. The fractional uncertainty is delta L over L. I don't tend to use that one very much, but for the sake of argument anyway, I'm going to give it a symbol. Uncertainty fractional on L. The one I use more commonly is the percentage uncertainty, which is uncertainty percentage on L is the absolute uncertainty on L divided by L times 100%. I prefer the percentage because it's more human readable. Then if what you're doing is you're adding or subtracting values that have an uncertainty, so for instance if you were taking the length of an object by measuring the position off of both ends of a ruler, you need, so z is x plus y or z is x minus y, then the absolute uncertainty on z, delta z, is the absolute uncertainty on x plus the absolute uncertainty on y. Multiplying or dividing, which is much more common actually in your equations in physics, you will need the percentage uncertainty. So if z is x times y, or z is x divided by y, then the percentage uncertainty on z is the percentage uncertainty on x plus the percentage uncertainty on y. And note that it's plus for both of these, regardless of which one of these you're doing. If you're adding two values or subtracting two values, you add the absolute uncertainties. If you're multiplying or dividing two values, you add the percentage uncertainties. If you're raising a quantity to a power, so if you're trying to work out the volume and you've just worked out the length, you could work out the volume, which is L cubed, if it's a regular cube. So z is x to the power of n, so the percentage uncertainty on z is n times the percentage uncertainty on x. You can work out the uncertainties in gradients and intercepts just by taking half the range. The modulus there is just to make sure that it's a positive quantity. And if you're doing some other function, which isn't addition, subtraction, multiplication, division, or raising to a power, then the easiest way to do it at this level is to do half the range as you did with this. You apply the function to the maximum version of that quantity, x plus delta x, and to the minimum version of that quantity, x minus delta x. Take the modulus, divide by 2, and that gives you the absolute uncertainty in sine x. So that is the theory. Now we're going to need to try some examples. So here we've got A. We can calculate the mean. We can calculate the uncertainty by half the range, and we can calculate the percentage uncertainty. So we'll just do that one as an example, and then the rest I'll leave symbolic. So 121 plus 118 plus 119 divided by 3 gives us 119. And what I'm going to do is I'm going to leave it to the same number of significant figures as this. That's important. Absolute uncertainties we tend to quote to one significant figure. Percentages, because they tend to be inside a calculation, we can keep an extra guard digits, so I tend to write them to two significant figures. The uncertainty here, we're going to use half the range. It's commonly the way of doing it. So 121, the biggest, minus the smallest, 118, divided by 2. Well, that's 1.5, so I'm going to round that to plus or minus 2. And the percentage uncertainty, 2 in 119 times 100% gives us well, that's my calculator says it's 1.7, but I can keep 2 sig figs, so I'm going to keep it as 1.7%. For this one, a squared, the percentage uncertainty of a squared is 2 lots of the percentage uncertainty on A. And this is how I tend to write it. The percentage uncertainty on A times B is the percentage uncertainty on A plus the percentage uncertainty on B. C over B, percentage uncertainty on C plus the percentage uncertainty on B. C times B, percentage uncertainty on C plus the percentage uncertainty on B. Let's try a much more complicated one. Here we go. Let's try this one. I'm going to call this Z. The percentage uncertainty on Z is, well, I've got 2 lots of this and that and that. So 2 lots of the percentage uncertainty on I plus the percentage uncertainty on J plus the percentage uncertainty on K. And that's it. You could do much more complicated versions of this, but usually physics equations have just things multiplied together. So this will do for now.